and welcome to another WJEC A-Level Physics question. This time it's question 2 from January 2004's PH2 paper. In a physics practical class, a teacher gives a student a sealed box with two terminals containing a combination of two resistors. One has a known value of 10 ohms and the other is an unknown resistance X. And the student finds that when a PD of 15 volts is placed across the terminals, a current of 2.5 amps flows through the combination. And first of all, we're going to find the resistance of the combination. Well, here we can simply use R equals V over I. We've got 15 over 2.5, which is 6 ohms. And then we have to explain why the resistors cannot possibly be in series. Well, when resistors are added in series, the total resistance is bigger than any of the individual resistors. And this 6 ohms is less than the 10 ohms. So let's just say something like resistors added in series give a greater resistance than any individual resistor. Next we're going to add the resistor combination to complete the circuit diagram below. So we just want to make sure our two resistors are in parallel. 10 ohms here, and X ohms there. For the same PD of 15 volts, we've got to calculate the current in the 10 ohm resistor. Well, that 15 volts is completely across that 10 ohm resistor. If we find difficulty in these questions, what's a good idea is to label potentials at different points. By convention, the negative side of the cell is labelled as 0 volts, and hence the positive side is 15 volts. There's no drop of potential as charges pass through a wire, so the potential at this point is still 15 volts. Potential at this point must be 0 volts because no potential drop across this wire on the right. So taking that same rule about no potential drops across wires, we have 15 volts here and 0 volts here and here. So you can see easily that the PD across that 10 ohm resistor is 15 volts. To calculate the current, I equals V over R, 15 over 10. That will give us 1.5 amps. To find the current through the other resistor, we're just going to remember that the total current in the circuit was 2.5 amps. So if you like, there's 2.5 amps here, splits into 1.5 amps through the top resistor, therefore there must be 1.0 amps through the lower resistor. Hence, to calculate the resistance of X, we can use V over I. We know that there's 15 volts across it and its current through it is 1 amp, so we end up with R of X is 15 ohms. Use an appropriate resistance combination formula. We've got to check whether the answers to 1 and 4 are consistent with each other, and we've got to show our method clearly. Well, resistors in parallel, we add in reciprocals. So we've got resistance at a parallel bit is 1 over R1 plus 1 over R2. So what we've got is that the parallel combination theoretically should be 6 ohms. That's what we worked out in part 1. Resistor 1 is 10 ohms, resistor 2 is 15 ohms. If we look at that right hand side, we can give a common denominator of 30. We've got 3 over 30 plus 2 over 30, which is 5 over 30, which cancels out to 1 over 6. So both sides, the parallel combination and the resistance that we calculate in part 5 both give us that 6 ohms. So yes, they do agree. And part B, which step in part A relies on conservation of charge? And we're going to briefly explain our answer. Well, it's this step here where we found the current through the other resistor. So it's A, part 4, part 2. And it's because current is the rate of flow of charge. So there must be the same amount of current entering the junction as leaving the junction. Thank you very much for listening. Please remember to like and subscribe. Feel free to leave any comments. Goodbye.